Hey everyone, today we're going to find the LCM, or the least common multiple, in a few different examples. In the second one, we'll kind of see an application of the LCM. Okay, so for the first example, we're going to find the LCM for 6 and 10. Now the least common multiple is exactly what it sounds like. It is the smallest number that is both a multiple of 6 and a multiple of 10. Okay, so one easy way to do this is to simply list out the multiples of each number and to create an actual list. And so if we go ahead and write down the multiples of 6, we'll have 6, 12, 18, 24, 30, and so on and so forth. If we do the same thing with 10, if we use your time, 20, 30, and you'll notice right away that 30 pops up in both lists and is the first number to do so. It's the smallest number to do so. It is the least common multiple of both 6 and 10. And so quite simply, the least common multiple, the LCM of 6 and 10, is equal to 30. And this is how we write our answer. Now this comes across in many different parts of mathematics, and we use a ton as we get to higher level math. It's also something we use to add and subtract fractions, as we'll see in grade 7 math, grade 8 math, and so on and so forth. And so if you're asked to add 7 tenths plus 7 twelfths, so we rewrite this 0 a little bit nicer. To add two fractions or to subtract two fractions, we know that we need a common denominator, okay? We know that we have to find a common denominator. If it's been a while since you've done this, hopefully this has been embedded into your memory by repetitive practice. So a common denominator means the exact same denominator for both fractions. And so what we're being asked to do is exactly what we did in example 1. We're being asked to find the least common multiple, the smallest number that is both a multiple of 10 and 12. And so we're looking for the LCM of 10 and 12. And so we can go ahead, much like we did over here, we can write out the list of multiples for each number. For 10, we have again 10, 20, 30, 40, 50, 60, and so on and so forth. The 10s are pretty easy to deal with. And next we have 12, we have 24, 36, 48, 60, and so on and so forth. We don't have to go any further because you'll notice that we finally get our least common multiple of 60 popping in both lists of multiples. And so that's exactly what we're going to use for our common denominator. We can even write, just to practice our notation, we can write LCM of 10 on 12 is equal to 60. Much like we wrote over here, just to have proper notation. And then we can go ahead and convert these fractions into equivalent fractions with a common denominator. And so to do that, we're simply thinking to ourselves, what do we multiply our original denominator of 10 by to turn it into a denominator of 60? And clearly 10 times 6 does the trick. Now we need an equivalent fraction to 7 tenths, and so we have to multiply by 6 in the numerator as well. So 7 times 6 brings us to 42 sixtieths, a nice equivalent fraction. And similarly, 12 times what will bring us to a denominator of 60? Well, that's the 5th multiple in the list, one easy way to count. And so since it's the 5th multiple, we know that we have to multiply by 5, and in keeping our fractions equivalent, we multiply the numerator by 5 as well. And so 7 times 5 brings us to 35 sixtieths. And now that we have our nice common denominator, we can simply add the numerators. And so in the end, we get a sum of 42 plus 35, which is 77 sixtieths. If you'd like to write this as a mixed fraction, if you're practicing, or 1 and 17 sixtieths. And there we have it, okay? So we can use this also to compare ratios. If we have ratios with different numbers, then we want to compare them in getting the same number in the second term. For example, if this was a ratio of 7 to 10, this was a ratio of 7 to 12, we could use a very similar solution written in the form of ratios. Again, looking for the least common multiple to kind of do the work that lets us compare the ratios, much like it does for the fractions. So I hope this kind of gives you a base understanding of LCM, a few applications of its use in mathematics, and thanks for watching.